Welcome back, everyone. Now it's time for implementing VLANs in our network. And why in the world do we want to create VLANs? Because it has benefits. What type of benefits? Well, we've talked about it before. All right, you're gonna get security. All right, you're gonna get you're breaking up the broadcast domain at layer 2, so you're increasing efficiency, bandwidth. All right, better administration. We've talked about these things. So VLANs is the way to go. You want to separate things, whether it be through floors, through departments, however it is that you're going to do it. All right, but definitely VLANs, you must create a network. All right. This is funny, but okay. How to name a VLAN? It's not required, but it's recommended. You don't need to name a VLAN, but why in the world would you let the iOS name it itself a number? Hey, how are you going to remember that the accounting, if you have 30, 40, 50 different departments or 100 floors, how are you going to remember, numbers? Come on. We're human beings. So once you create the VLAN, you name the VLAN. Let me go a little bit further than that. All right. And I repeat myself, I believe, in the lab. Somebody asked me one time, hey, Laz, can we assign the VLAN and then create it? It's like who comes first, the chicken or the egg? Why would you assign something to something that doesn't exist? Yes, you can. And then it will tell you, well, the VLAN doesn't exist. Do you want to create it? And you say yes at that point, and then it gets created for you. All right, but don't do that. Don't. Create the VLAN, name it, and then assign it. There's an order to things. Okay? Okay, not that you have to follow it, but like it says, it's recommended. All right, name your VLANs. We're going to talk about trunk ports. All right, we're going to use the 802.1q protocol. All right, that is the latest protocol that we use for intra-VLAN routing or whatever it is. We're going to use 802.1q. When you trunk your port in a layer 2 switch, that is the encapsulation that is used. Okay, and obviously we're going to talk about the BTP protocol itself, because in trunk ports only, it's basically for tagged VLANs, meaning VLAN or that need to be tagged. VLANs that are not the native VLAN. The native VLAN can go through access ports or trunk ports. But all other VLANs need to be tagged. So that's why you must trunk the ports. So when they go across, these VLANs can get tagged. And obviously, and it tells you right there why the native VLAN can go across any type of port, because it has a PVID, a personal virtual VLAN identifier. Personal VLAN identifier. So when it's going across, then there's the native VLAN. Go ahead. This is the native VLAN. Go ahead. But be careful. That's why we have the BTP protocol as well. Okay, that says, hey, the native VLANs must be the same. All right, and I talk about it inside the labs as well, but I want to make sure that you understand that. Not only, yes, you need to make sure that your VLANs, your native VLANs, are all the same number. If it's 99, if it's 200, if it's 1, if it's 5, whatever it is, they all have to be the same. Or you may run into issues, all right? Because you will have something, it will start popping up, a native VLAN mismatch. Okay? All right, with that said, I'll see you in the next. All right, we're going to go inside the lab now. I'm going to configure VLANs. We're going to create a VLAN. We're going to name a VLAN. We're going to assign a VLAN. We're going to do it a special way. I'm not going to give away the surprise until we get in there. But I'll tell you this much. We're going to do it right here. We're going to name them. We're going to create them. We're going to name them. And we're going to assign them down here. What? That's right. Let's get inside the lab and let's get this done. All right, welcome. And now we're in our VLAN lab. We're going to actually create, name, and assign a VLAN. All right, but we're going to do it in a special way. It's very easy just to go inside each individual switch, create the VLAN, give it a name, and then assign it to a particular port or ports. But we're going to do it a little bit different in combination with other features that we're not going to talk about in detail now. We'll talk about it in detail later. But so you can see how things would work. So we're going to go to our root bridge here, and we're going to verify. Always verify, ladies and gentlemen. Always verify. As you can see, that that switch was configured already with the with the common commands. So we're going to do show. What was I trying to do here? Okay, we're going to assign the VLANs here. Okay, yeah. All right, so we're going to do show VLANs. All right, and as you can see, we're all part of VLAN 1, the default VLAN. So we're going to create the actual VLANs, which is VLANs 10 and 20, up on this bridge or the switch. All right, we're going to do config T, and we're going to do VLAN 10 name HR. VLAN 20 name account. All right, well, let's not put them in lowercase. We don't want to make them feel bad. All right, so we just created, let's copy this, and let's do show VLAN now. We just created and named 2 VLANs. Now, it is recommended that you name your VLANs. You don't have to. All right, and if you name a VLAN, meaning you instead of creating the VLAN first by doing VLAN 10, enter, for whatever reason, I've asked this question has been asked. Can I name the VLAN first and then, well, yeah, you could, but why would you do that? But the actual iOS is intelligent enough to say, all right, listen, this VLAN doesn't exist. We're going to go ahead and you want us to create it? Or not name it, assign it. They will tell me, hey, Laz, can I assign the VLAN before I create it? You know, the chicken before the egg? I don't know. But whatever. Yeah, you could. And then it's going to say, well, what VLAN do you want? It's not created. Do you want to create it? And you say yes, and it creates it. But don't do that. Okay? Create the VLAN. Name the VLAN. Now, you can see that it's not assigned to any ports. It's not assigned to any ports. All right, so we got VLANs 10 and 20. VLAN 1 is there by default and all switches. So the next thing that we're going to do, go back to global configuration. So we named it. We're going to go and build a domain name or domain, I should say. VTP domain. And we're not going to get to the details of this because there's a lecture on this. VTP domain LAS. Okay? And I'm going to show you it. Do show VTP stat. All right, when we get there, you'll see. And the reason you're getting this information, we'll explain everything when we get into this virtual trunking protocol lecture. But here's the domain name that I want to use because I want all our switches to participate within this domain name. If you don't have this domain name, then you cannot participate with our updates. All right. And finally, again, not getting into too much detail, I'm going to trunk a couple ports. And the ports that I'm going to trunk are ports 22, 23, and 24. And again, this is important. All right, this is important for it to happen, but I'm going to talk about it right now. But you need to do this. You need to trunk ports. I'll just give you the basics. Anything other than the native VLAN has to go across the trunk port. Anything other than the native VLAN has to go across the trunk port. But we'll talk about trunk ports later. All right, so we're going to go int range F0/22-24, and then we're going to go switch port mode and then trunk, do WR. All right, and if you were to do a showing trunk, you see the ports are trunked, and this is the reason that we're doing it. All right, not to mention other reasons as well. All right, but again, later. Now that we've done that, we've created the VLANs, we created a domain name, and we trunk the ports. You see how things are changing here. The lights are turning from green to amber and so forth. All right, so we're done with this switch right up here. All right, and we're gonna go to this particular switch right here. Let's maximize it. No, let's not maximize it. Let's restore it to its original size. A spooky guy there behind me. Keep me on my toes. All right. All right. So now, once we get over here to the switch, one of the things that we're going to do, and again, we'll talk about this in a bit, it already has the basic configurations on there. we're going to do BTP mode client. Okay? And then we're going to do show VLAN. And look at this. The VLAN showed up down here. So it cuts your job in half. You create the VLANs on the root bridge, on a one main bridge switch, and then you have the VLANs trickle down by themselves. So you don't have to create them anywhere. All you gotta do is assign them. All right, and let's do that. Let's assign the VLANs. So we're gonna assign it to ports 1 through 15. So we're gonna go int. Let's bring this down more. There we go. All right, so we're gonna go int range F0/1 through 15. Okay, enter. Switch port mode access. They must be access ports in order for you to do this. Switch port access VLAN 10. Do WR, do show VLAN. And now you see that VLAN 10, and what does it say? Oh, VLAN 10 is HR, correct? Yes. VLAN 10, right here, these are the ports that are assigned to it, right? So we assign those ports to VLAN 10. Awesome. So we're done. We're done. All right. We've created a VLAN. We've named the VLAN, and now we've assigned the VLAN, but we did it a little bit differently because we did the VLANs. We created the VLANs up here. We named them up here, but we assigned them down here. We have to do those little tricks that I showed you in order for that to happen. All right, so let's go ahead and open up the last switch here. Let's move it over here. And we're going to do the same thing. Config T, BTP mode client. All right, let's take a look to verify that those VLANs came down. They did. There's 10 and R right there, or 10 and R, 10 and 20. But we don't want that. We want to assign. Well, we want that, but I'm saying we want to assign just 20 though. So we go int range F0/1-15 switch port mode access. One too many S's. It can guess it needs an S, but if you put one more than it has to, it'll give you an error. Switch port mode access, and then we go switch port access. What about access? VLAN 20. Do WR. Do show int brief. Sorry, that was on a router. Do show VLAN. Do show VLAN. Or your show VLAN. Okay, so now we see here 20. That's accounting department. Is part of all these ports right here. So we've created the VLAN. We've assigned the VLAN. All right, we've named the VLAN. It's done. Now we've created them and assigned them up here. Like I said again, we had to trunk the ports, create a domain so everybody can be in the same domain. All right, but it cuts your work in half. They're trickling down for you, so you don't have to create them down here. All you have to do is assign them. All right, the benefits of creating these VLANs. All right, we're now logically segmenting the network. What happens in 10, meaning we've increased the number of broadcast domains. Meaning what happens in VLAN 10 stays in VLAN 10. If you're accessing printers, if you're going to the internet or whatever it is, it's not going to go outside VLAN 10. It's going to go into a direct path because now eventually everything's got to go to that router. And that router is going to be doing the routing to where it needs to go. So you're increasing the bandwidth on your network and you're securing it because if you don't give access to a particular network to go into that VLAN, they won't be able to. Okay, they will not be able to. All right, so let's go ahead and that's it really. So is just assigning, creating, naming, and assigning of a VLAN. All right, in a special LAS's way. I'll see you guys outside the lab. How cool was that? Huh? Cut your workload in half. You create the VLAN here, you name the VLAN here, then you create a domain in the VTP using the VTP protocol, right? VTP domain LAS or whatever, Cisco, whatever you want to put. Okay. And then you trunk the ports accordingly. Obviously, these ports need to be trunked, and they'll get trunked dynamically. All right, because they're in dynamic auto. All right. This is turns red because this guy's not on or doing anything. So that's why you see that red. But once we get there, you'll see how that turns on. And you see how the VLANs came down because we changed, this is a server. We changed the VTP modes down here to client, right? And then we saw how the VLANs came down. They came down. And then just assign whatever VLAN. We assigned to VLAN 10. I assigned it to VLAN 20 in the range of ports. That's it. But we had to turn the ports to switch port mode access. Keep that in mind. In order to assign the VLANs or to do any kind of security, they must be in switch port mode access. If not, it will give you errors. All right. But that wasn't too hard. That was very simple. See you in the next one. All righty. Now we're just going to take a look at that virtual trunking protocol. We're going to go inside and we're going to take a look and see the important things that we need to see about that. Switch mode, is it in a domain? The revision number, not the revision number, the revision number, okay? To see if it's lower or higher. And at the very bottom, who just updated me? So these are the things you want to look at. This is what VTP does. On top of which, if we're in a domain, if I put Laz here and I put Susie down here, well, we're not in the same domain. But we're connected together. So what's gonna happen? You're gonna have a VLAN, a switch, VTP domain mismatch. VTP domain mismatch. Okay. So, but enough talk. Enough talk. Let's go inside and let's take a look at the VTP trunking protocol. All right, welcome back, everybody. Here we are now in the virtual trunking protocol lab. Now, we just created our VLANs, we assigned them, we did all that good stuff. All right, but now let's take a look at this virtual trunking protocol. So we do a show. This is the top switch, switch 0, this one right here. Okay, so we're going to show VTP stat, which stands for status. All right, but to tap that out, that's what it would say. All right, what information are we looking at here that's important? Well, one of the first things that we did in the previous lecture is we gave it a domain name. That's definitely what we wanted to do. And you can see the VTP operating mode is server. And remember, we talked about the operating modes, that there's 3: server, client, transparent. Server is going to update, send updates, and receive updates of its VLAN database. Okay. Another important number that we want to look at, you see the revision number here is 0. Okay, so since it's 0, it will accept updates from the other switches. Okay, it will accept updates from the other switches. And you can see, and this right here is extremely important. Configuration last modified by the 192.168.253. Okay, and it tells you the date, the time, whatever. All right, and the local updater ID is 1.253. So it tells you who just, what was the last time that there was some sort of update or modification done to this particular switch. So this show VTP status command is very important for your certification, for your real world scenarios, because it lets you know. Now here, as far, if you're doing MD5 or traps, or you do any kind of pruning or shaping of your traffic, you can do this. You can put passwords on here. You can see how many VLANs are supported. You can see the version of VTP that you're using. That's fine. But the important things you need to focus on: the configuration revision number, the operating mode, is there a domain name? And the domain name has to be identical. Uppercase, lowercase is case sensitive. Okay, or else you're going to get a VTP domain mismatch. VTP domain mismatch. And then obviously these lines down here. Who was the last person that actually updated me? Because that way you'll know which switch is what. Okay, so this is what you look at when you're doing your VTP, right? Because VTP, people get it confused with trunking. It has nothing to do with that. The virtual trunking protocol, actually all it does is what you see right here. We can change the operating modes. We can put a domain name with a password. We can shape traffic. All these different things, okay? and it lets us know, what you see highlighted there at the bottom. So that's what we did earlier. Earlier, all we did was put a domain name. And the only reason I did that, so the other two switches I don't have to do that on the lower switches. They can go ahead and just participate all on their own, okay? Because it's going to come down because the ports were trunked. And we'll talk about trunking in a little bit, all right? But that is what VTP does. And if you were to do a show VTP, and you do a question mark, you can look at counters, password, status, right? If you want to look at the status of it, right? It's going to give you the same thing, right? That's what we just did. Or show VTP, counters. You're going to do that, but they don't really get into things of this nature, okay? The one that you need to know is this, show VTP status, because what you want to look at is what I just told you right now. And again, revision number, operating mode, domain name, and who updated me. All right? This is important. This is important. All right, so let's go to another switch and see what that looks like. All right, let's go to this switch right here. Control C, Control Z, sorry. Show VTP stat. All right, and the same thing. And you can see that this configuration was last modified by 1.253, which is the top switch. It was to send the information down about the VLANs. And it's giving you, again, the time and date and what have you. All right, but you can see we're all part of the LAS. But look at the operating mode. Is client mode. So this is why this is very important. You need to understand it. And it also actually, as VLANs go across, it makes sure that they get tagged. They get tagged as well. It maintains the VLAN database. It looks at things going across. So VTP does do a lot of things, all right? Because you can only have one native VLAN. So if your native VLAN on one switch is 1, then on the other one is 1. If your native VLAN is 99, then all native VLANs must be 99. And this maintains it that, hey, we got to make sure that we don't have a native VLAN mismatch. So this also does it as well. This also looks at it as well. Okay? All right, so this is what VTP, the virtual trunking protocol, actually does. Okay? So not to get it confused when we trunk ports, but what this one, which is something completely different, this one is just, again, looking at the things that we just talked about. All right, I'll see you outside the lab. All right, so there you go. There's your VTP trunking protocol. Very important. You saw things we pointed out. All right, we saw things we need to point out. And at the bottom, those IP addresses. Why did those IP addresses show up? Because we put IP addresses on each switch. That's why they're sharing their VLAN database and they're updating each other. All right, so you need to know who was the last one that just updated you. You may get a question like that. So you do the show VTP status, you will see that. Okay, so a very important protocol, not to mention that it maintains the domain names and it maintains the same type of native VLANs going across. Very important, but very easy. Now that you know the secret to VTP. See you in the next one. All right, we went over VTP, which is the virtual trunking protocol. Now we're going to talk about the trunking of ports. Two different things. We're going to go inside here and I'll show you, okay, the show in trunk, and I'll show you the command again. All right, because we did it when we did this, but it's just going to put the encapsulation type, which is 802.1q. And we do it because we have VLAN 10 and VLAN 20, and they can't go across access ports, so we must trunk these ports. All right, because once you trunk these two ports, dynamically, these two ports down here will be trunked as well. All right, so you got to make sure that those ports are trunked. But enough talk. Let's go inside the lab and let's take a look at it. All right, welcome back, everybody. Same lab, hasn't changed. All right, but now we just finished doing the virtual trunking protocol. We found out what that was. Now we're going to talk about trunking ports, which we already did. Show, this is switch 0, which is the very top switch, the root bridge. Show int trunk. All right, as you can see, we already trunked some ports 22 and 23. We did trunk port 24, but you're not going to see it here because router 0, its interface is off. Therefore, that port 24 of the switch is going to be off as well. But the main purpose of it is to get this protocol going. The only VLAN that can go across access ports. If you remember when we created VLANs, we actually said, hey, when we were assigning VLANs, I should say, we did switch port mode access, right? In order to assign the VLANs, they had to be access ports because by default, all ports are dynamic auto. But only the native VLAN, the default VLAN, the management VLAN, the admin VLAN is the only one that can go across access ports and trunk ports. All right, it can traverse across those ports without a problem. Okay, but VLAN, any other VLAN cannot. They must go across trunk ports so they can get tagged and say, hey, you belong to VLAN 10, you belong to VLAN 20, you belong to VLAN whatever. So they know where they need to go. VLAN 1, or the native VLAN, what it has a PVID. It's a personal VLAN identifier built in within its frame. So as it's going across, the trunk ports see that. They see that, oh, okay, well, if this is the native VLAN, go ahead on through. But if you do not trunk a port and you try to do VLAN 20 and try to make it ping the router or go across to any other VLAN or to the same VLAN on another switch, it's not going to be able to if that switch port is not trunked. And that's extremely important because that's one of the things that Cisco really wants you to know. All right, they need you to know that everything that's not the native VLAN must go across trunk ports. It could be called a tagged port as well, okay? And the native VLAN could be called untagged because the native VLAN has a built-in tag already. All other VLANs need to be tagged, which is called frame tagging. It assigns that hey, you belong to VLAN 10, you belong to VLAN 20, and so forth, okay? So that's what trunking does, because when we finally do inter-VLAN communication, that encapsulation that you see there highlighted, 802.1q, has to match on the router and on the switch. All right. It used to be ISL, just like with span tree that it used to only support ISL. Now it supports the newer type of encapsulation, okay, or trunking, which is 802.1q. Okay. So 802.1q is the type of encapsulation we need to have. All right, for intra-VLANs, for anything. If you're doing on this layer 2 switch, all right, and you simply go in and go switch port mode trunk, you trunk. But in layer 3 switches, this is what I was talking about earlier, that if you try to trunk a port, what's going to happen is it's going to choose, because it'll support both ISL and 802.1q. So it's a long switch port interface, blah, 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 you know, and then trunk, and then you can put ISL, whatever. So it's different syntax. That's all. That's all. But it'll allow you to use two. Here, these layer 2 switches, which is what Cisco's focusing on, it's just layer 2. So when you trunk port, it's basically going in the port, and you've done it already, config T, and let's just pick port 24, F0/24. It's already trunked anyway, and you do switch port mode, and if you look at it, there's different modes: access, dynamic, trunk, and everything is set to dynamic auto anyway, but we want to explicitly tell it trunk, and we already did, so there's really no need to tell it. But this is how you would do it, and that's how you will look at it later on to see if that port is trunked indeed. If I don't trunk that port and we were trying to do inter-VLAN, PC1 will never get to PC0. Never. Because it will not be able to make it to the router because it is not trunked. It is not trunked at all. And in this situation, since we have different networks, it has to go to a router so a router can route between one network and the other. Okay? So that is what trunking is. This comes back from the days of telecommunications where they had a whole bunch of wires, you know, lines going to this one huge trunk cable, right? Or pole, whatever you want to call it. conduit where all these cables went through and carried all sorts of different types of communications and what have you. This is the same thing. Trunk ports carry multiple VLANs, okay? So this is the purpose of trunking port. As you can see, it is nothing to do, or it doesn't, with the VTP, the virtual trunking protocol. Two different jobs completely. So don't get them confused. Do not get them confused. All right? So there you go. Make sure, and I'm trying to emphasize this, make sure that if you do not have communications, let's say in this topology you see here on the left, VLAN 10, VLAN 20. Let's say you have VLAN 10 on the other side. And you have VLAN 20, you have VLAN 10 and VLAN 20 on both sides. Right? But only VLAN 1 can communicate across. Well, the problem is that VLAN 10 and 20 don't have a P-bit. So that means that the ports between the switches are not trunked, and they need to be in order for them to have communications. Okay? For same VLANs, no routing obviously. It has to be, VLAN 1 to VLAN 1, VLAN 10 to VLAN 10, VLAN 20 to VLAN 20. If you want to go VLAN 10 to VLAN 20, then you got to go up to the router and back down again. All right? But other than that, that's it. That's all there's to that. So pay very close attention to that, because there is a command, show switch port. Of course, show switch ports. Let me maximize this window. So I hate when this makes it easier to look at. Okay, show VLAN switch port. Nope. So interface switch port. There you go. So I know there's one of those. Show interface switch port. This looks like a pretty familiar print screen. All right. You can see right here, encapsulation .1Q. Okay. Native is always going to be operational. All right. But these are things that you want to look at. Encapsulation .1Q. All right. If that is not on and it says access, not trunk, then that's why it's not going across. Okay. So here's the command to take a look at that. So show int switch port. And it's going to show you the ports, and what they are. Okay. And you can see, you can go through each and every port. One of you can just do switch ports, show interface switch ports. I don't think that's all. You can put the output modifiers, okay. Or you can just, go all the way through. Here's gig 02, gig 01. Here's port 24. You see all the switches, 23. You see it's trunked, .1Q. All right, so that's what you need to see. If you don't see that, then that's your problem. Those ports must be trunked. All right, enough of that. I think we killed that to death. I'll see you outside the lab. There's not really much to say. That's what it is. It is what it is. They're trunking ports. You got to turn them on if you have VLANs. All right, from switch to switch, from switch to router. We didn't do it this way because we're really not trying to communicate. Well, we are trying to communicate this way, but they're in different subnets. So they're going to go to the router and then come back down. If we wanted them to go straight across, let's say I have VLAN 10 over here or VLAN 10 over here, then we will have to trunk these ports or trunk that port in order for it to go across as well. All right, that's all there is. That's the purpose of trunking ports. I'll see you in the next. All right, we're getting there. We've done a lot of things. Now we're going to secure our ports. We're going to do switch port security on these switches down here, on the client switches, okay? We're going to do ports 1 through 15. We're going to do switch port security. We're going to allow only one MAC address because we're a rigid administrator. And if you try to be funny with me, I'm going to shut down your port. So we got to tell all that. And at the same time, we're going to do a little extra thing in there that we didn't do in spanning tree. We're actually going to turn off spanning tree down here. All right, but we're going to protect against somebody that didn't get the memo that, hey, don't plug in a hub or anything like that, an internet working device to these ports because spanning tree is not looking at it. Okay, So we're going to guard against it by using the BPDU guard enable command. All right, so we're going to do a couple things there. So let's get to it. Let's get inside the lab. All right. So we've done quite a few things, from spanning tree to VLANs, assigning them, naming them, creating them, assigning them, naming them. We did the BTP modes. We saw those. All right, we trunked the ports. Now we need to secure the ports. And now the ports that we're going to secure are the ports down on the actual VLANs, VLANs 10 and 20. We're going to secure those ports 1 through 15. All right, we're going to put switch port security on them so nobody can go in there and actually just pull, take out a PC or put in a PC that does not belong. Okay, this is why as an administrator, not only do you need to, it's important for the configurations, but physical access and allowing your employees to bring certain things to work, you need to look at. You shouldn't leave open ports. There's a lot of things that we'll probably talk after the lab, but there's a lot of things that you need to do to make sure that nobody can actually mess around in your network or plug things into your network that you don't want them to. Okay? But anyway, so we're in switch 1. We're going to go into the range, config T, conf T, all right, int range F0/1-15. I'm going to go do switch port. Well, it's already access because we did it there, but let's do it anyway. Switch port mode access, right? And switch port TCH, switch port -security. That enables it. If this would have been dynamic auto, it wouldn't have done it. Now we already did VLANs on there, so it was in switch port mode access anyway, but doesn't hurt to type. But switch port -security actually turns it on. Okay, then you can up arrow and you can say Mac sticky. And let's go ahead and bring this out a little bit so you can see the commands. Mac sticky. And what does that do? What that's going to do is it's going to learn the MAC address dynamically once the PC goes through it and what have you, but it's going to show up as static. It's going to be stuck to the MAC address table until you decide to take it out. Okay? So that's it. So whichever MAC address it learns, that's the MAC address of that computer. Nobody else can use it. So, but we also need to make sure that nobody else uses it by doing a maximum of only one. So once it learns that one computer, anybody else tries to plug in to that port, okay, they're not going to be able to. That port's going to shut down that port because we're going to tell it to shut down, and it's going to be in what's called error disable state. Error disable state. All right, and then you go switch port. I should have just done that. Port -security. Viol, which is short for violation, and we're going to do shut, meaning I want you to shut down the port. All right, I want you to shut down the port because I don't want anybody to actually access this particular switch. But you know what? While we're here, okay, one of the things that we didn't do in spanning tree, because we really don't need spanning tree looking at our access ports where our computers are at. So what we're going to do is we're going to do span tree port fast. We're going to turn it off. All right, and it gives you all this warnings. Hello, you sure you want to do this? Of course we do. And it was spanning tree BPDU guard enable. What did we do? Well, with spanning tree port fast, in the range of ports we're in, we actually told spanning tree, do not look at these ports. Don't worry about what I plug in. As soon as I plug something in, make it designated forwarding. That's what that said. So spanning tree's not even looking at these ports any longer. All right, and this right here, you're putting a guard in those ports, and they're looking to see if they see any bridge protocol data units, and if they do, they're going to shut down the port as well. Because remember, spanning tree is there to look for switching loops. That's why I'm telling you, are you sure you want to do this? Because if you plug in any connecting hubs, concentrators, switches, bridges, etc., can cause a temporary bridging loop. All right, because now you have another type of redundancy from somewhere else, another internetworking device, and spanning tree is not looking at it. It could be that you can cause a loop. So make sure everybody gets the memo. All right, so we just turned off spanning tree and we actually guard against anybody plugging in another internetworking device to prevent them from creating a loop. And it'll be easier if you just email them. All right, so let's do the switch 2. Let's do the same exact thing. All right, so you can see the commands. Config T, int range F0/1-15. And then we go switch port, no, switch port mode access. I got ahead of myself. Then switch port hyphen security to enable it. All barrel, Mac sticky, not Mac, Mac's a Mac address, Mac sticky. And then all barrel, Max 1, all barrel, BIOS shut. Okay, and then let's do the span tree for good measure. Span tree port fast. And then spanning tree, vPDU guard, enable. All right. So we did security. We're creating our network more efficient, and that's what we're doing. We secured the ports, but as well, we turned off spanning tree because we didn't want spanning tree to look at those, so we can plug things in and immediately the light will turn green and we'll be able to use those ports right away. We won't have to wait those 30 to 90 seconds for it to converge and think about, hey, who's plugging into me, this and that. All right. So there you go. That's switch port security and turning off and securing your ports with spanning tree. See you outside the lab. All right, that was pretty simple. I keep saying that, don't I? Everything's pretty simple. But you can see it is. It's not rocket science, okay? Just gotta understand what it's doing. All right, you enable switch port security. You make sure that those ports were access ports, and they were because you assigned the VLANs to that. And then you go, hey, I want this to be a MAC sticky, meaning I want you to learn it dynamically, but I want it to be assigned to the MAC address table statically. Okay? And then the maximum number of MAC addresses is 1. That's it. A computer that I give you, and that's it. And if you violate that, your port's gonna get shut down. All right, and then you saw how we did spanning tree port fast. That turns off spanning tree in those ports, and it gives you a huge warning, right? And that's when you copy paste into your email, into the memo, and let people know, hey, don't plug anything you don't need to. All right, and then you're probably the only IT individual in there, so you know already. And then we guarded against there by using the spanning tree BPDU guard enable command, which will also, if it sees any bridge protocol data units, it will shut down the port into error disable state. You will literally need to go in there, do a shut, no shut to turn that port back on. All right, so we did quite a few things, but again, it wasn't that difficult. You can pretty much up arrow or tap through the whole thing and you'll get it done. And that's it. I'll see you in the next. Well, we've made it to the summary, right, of this particular section. We covered quite a few things. We've learned how to create a VLAN. Oof, that was difficult. We created it, we named it, and we assigned it, but we did it the special way, right? Laz's way. We did it in the root bridge. We created it and named it in the root bridge and then assigned it in the bottom. How? By trunking the appropriate ports and then by creating a domain using the virtual trunking protocol. All right, and we looked up the virtual trunking protocol. All right, we saw what it does. All right, what it is in charge of making sure that everything stays within the same thing, like the BTP domain. There's no mismatch because they're all named the same. They're case sensitive, so they gotta be the same. And as native VLANs, it also pays attention to if the native VLANs are the same. If not, you have a native VLAN mismatch. Trunking ports is turning on that 8021Q encapsulation for those VLANs other than native VLANs because they need to be tagged. They need to be tagged to what VLANs they belong to. We went ahead and used switch port security. All right, we put in, hey, sticky. You're gonna learn it dynamically, but you're gonna put it in statically. It's never gonna come out, so I take it off. All right, we also did the amount of PCs or MAC addresses that can be learned on there. We put one, and then we actually put in there a violation that if somebody else tries to be sneaky, unplug and plug something else in there, that port's going to get shut down, right, or disabled state. And then we just did something to turn off span tree as a nuisance thing on the access ports. Doesn't need to be looking at my printer or my computers. Doesn't need to do that. Just let me plug it in so I can start working right away. Turn it to designated forwarding ports, and I can start sending information immediately. Okay, but we did guard against it. We did guard against it from switching loops by putting the span tree BPDU guard enable command. Okay, and that pays attention to any BPDUs coming in. That's hey, whoa, you can't come in here. You're an internet working device. I'm gonna shut down this port. So we did all that. So we covered quite a bit of things, but you saw that it wasn't that difficult. Practice makes perfect. All right. I'll see you in the next.